Okay, I'm going to try to do this on my iPad for you, but suppose we have a plane and we have a vector, and we'd be calling this the normal force, right? And we'd be calling this one the force of gravity. Normal force is elevated on an angle of theta. If we shift these axes, I'm going to shift this guy over here, and that's going to travel through an angle of pi over 2 minus theta. If that happens to the top, I shift the force of gravity in the same way. That'll be force of gravity in my new coordinate system, and it is also going to travel pi over 2 minus theta. When I do that, I set myself up, the original normal force is perpendicular to the new force of gravity in my coordinate system. So since I know this angle, and I know this is 90 degrees, I can say this is pi over 2 minus theta. Okay? I'm only going to consider now what's down in this quadrant here. So I'm just going to redraw that. Okay. So in my new coordinate system, I have this here leg is going to be my force of gravity in my new y direction, making this leg force of gravity in the x direction. And these are triangles. I can say this angle is pi over 2 minus theta, which means this angle is theta. Then I can start to consider these triangles separately. So let's go with my y force for that triangle. Got a little guy like this. Got my angle theta, force of gravity in the y direction, force of gravity in my new coordinate system. We know that sine is equal to the opposite over the hypotenuse. Okay, and if I solve that for my opposite side here, I would say that the hypotenuse times the sine of pi over 2 minus theta, because I'm actually using this angle here. This is 90, theta, that has to be pi over 2 minus theta. So hypotenuse sine of pi over 2 minus theta will give me the opposite angle, or the opposite side, which will be my FGY. Now, sine of pi over 2 minus theta is just another way of saying cosine of theta, which means my force of gravity in the y direction of my new coordinate system is equal to the hypotenuse, which will be equal to g, right, times cosine theta. Now I can do the same thing if we go back here for force of gravity in the x direction, considering this triangle. If I redraw this triangle here, if I know that's pi over 2 minus theta, I know that this guy is theta. Again, I want this here. I know this one here. This triangle is kind of hard to work with, so I'm just going to do the old flipperooski. Okay, this angle is still pi over 2 minus theta. Put my 90 degree angle there. That means original angle theta is up at the top. I can use cosine, which SOHCAHTOA tells us that cosine is equal to ca, which is the adjacent, over the hypotenuse, which means that the hypotenuse times the cosine pi over 2 minus theta is going to be equal to the adjacent side. My adjacent side is going to be FGX, I'm again using pi over 2 minus theta because I'm considering this angle here. Cosine of pi over 2 minus theta, that's a fancy way of saying sine of theta, which means my hypotenuse times sine of theta equals my adjacent side, which means force of gravity in the x direction is equal to hypotenuse, which is equal to the force of gravity times sine angle theta. So hopefully that makes sense.